essentially generate 50 newtons worth of thrust, and they help in attitude keeping, which is essentially making sure that the spacecraft points in the right direction. So that covers the pitch and yaw. What do we do about roll, one might ask? So we have like these small cold gas thrusters. They're placed along the periphery of the stage as well, and they fire in pairs. So with that, they're capable of generating a rolling moment to roll the vehicle. Now, this whole architecture that we talked about, it's something that answers purely to the requirements. It's powerful where it needs to be, and incredibly precise where accuracy matters the most. And this is a philosophy that we've extended beyond propulsion. So all our structures on the rocket are made out of carbon fiber. This is India's first launch vehicle which is made purely out of carbon fiber, and it's 5 times lighter than steel. We also employ advanced propulsion technologies. All our liquid engines are additively manufactured or 3D printed, and all of this, what it contributes to is it reduces the weight, it improves performance, and also increases manufacturing efficiency. The net sum of all these decisions is you have a rocket which is reliable, on demand, and affordable.
That's true, Suyash. So, an update for our viewers. Just a while back, we got a confirmation that the guidance, navigation, and controls team, they have successfully completed gyro compassing and the static navigation profiling of the lens package. This is done so that the rocket knows its initial orientation with extremely high accuracy. In the process, the inertial navigation system determines the initial attitude of the vehicle by identifying the true north and the gravity direction with respect to a rotating Earth reference frame. So quite unique it is.
That's true. And it's something very important for you to know where your orientation is before you make that journey to stars. It's sort of like using a compass when you're going out camping. You want to know where north is so that you can chart your journey accordingly.
जी सुयश, और आई थिंक वायुयान में भी इसी सिद्धांत का प्रयोग किया जाता है और वो उसी सिद्धांतों पर निर्भर करती है। तो यदि अब हमको ज्ञात है कि रॉकेट किस दिशा में जा रहा है, हमारा विक्रम 1 प्रक्षेपक यान, आज की इस पूरी यात्रा का लक्ष्य क्या है, वो किस ओर प्रस्थान करेगा?
Today's test flight is attempting a 450 by 450 kilometers circular low Earth orbit or LEO, a region of space widely used for Earth observation, communication, and technology demonstration. But this is a maiden test flight. So what matters most today are the fundamentals. Today's test flight has 3 prime objectives: executing successful stage 1 ignition and liftoff, clearing the launch tower safely, and then gather as much data as possible from our onboard sensors.
अवश्य विदय, जैसे आपने कहा कि ये एक प्रथम परीक्षण उड़ान है, इसीलिए आज सबसे अधिक महत्वपूर्ण ये है कि अभियान के प्रमुख उद्देश्य को हम जान ले। प्रथम चरण का सफल प्रज्वलन, यान का सुरक्षित उड़ान पथ से निकास और अधिक से अधिक उड़ान अंकों का संकलन। किंतु अंतरिक्ष तक पहुंचना अत्यंत महत्वपूर्ण है, ये हम सब जानते हैं, बट सही कक्षा में उपग्रहों को स्थापित करना एक कठिन कार्य है, राइट?
That's absolutely right, Akhil. It's not sufficient to just simply reach the right altitude. The rocket must inject the payload with the correct velocity, the right flight path, and the precise orientation so that the satellite begins its mission exactly as planned.
Yeah, that's right. Now that we know where Vikram 1 is headed, let's talk a bit about what it's carrying today. So what's on board today's mission?
Vikram 1 is carrying 2 deployable test satellites today. The first one is Scope, a test satellite developed in-house by us as a technology demonstrator. Joining Scope on today's mission is Solaris, a CubeSat developed by Aerospace, flying again as a technology demonstration payload. And from Germany, D-Cubed is testing 2 of its own systems, deployment and separation technologies built to work in orbit.
And there is one more interesting payload that we have is from Cosmoserve Space, and it's flying soft robotic arms along with the OEM stage that will attempt to capture a piece of simulated debris in orbit. That is a very interesting thing that they're attempting indeed. And it stays mounted to Vikram 1 throughout the entire flight. And if it works, it will be the first of its kind to demonstrate this kind of a experiment. and it's an early step to clearing the space debris in general. That's a great initiative, I think.
Yes, yes, definitely. And there's two more payloads on board, ones that celebrate creativity and India's scientific heritage. The first is Cosmic Bloom, a delicate floral diamond artwork from Cosmos Diamonds. The second is quite something else entirely. It's a micro art, an 18 karat gold rocket crafted by Telangana artist Ajay Kumar Matewada, holding three tiny sculptures of Nobel laureate Sir C.V. Raman and visionaries Dr. Vikram Sarabhai and Dr. APJ Abdul Kalam. Each one of them is smaller than a grain of rice, and it's a fitting tribute because all these three names essentially live aboard Vikram 1 itself. The Raman engines, the Vikram 1 vehicle, and the Kalam motors. Now, as we count down, of course, it's worth taking a pause to appreciate where this journey is beginning from. Vikram 1 lifts off from the first launch pad here at Satish Dhawan Space Center at Sriharikota, more familiarly called as the Shar Range, a place that has witnessed some of the most defining moments in India's space program.
That's correct, Suyash. This very pad has a proud history and legacy of its own. This is the exact place where Mangalyaan set off for Mars in 2023. And Sriharikota itself has launched India's greatest space journeys, like Chandrayaan to the moon, Aditya L1 to study the sun. And now, our very own Vikram 1 adds its own chapter on its journey to the stars.
That's right, Akhil. Missions like Vikram 1 are helping position India to serve the fast-growing global demand for small satellites, and they reflect a wider momentum as well. Under national initiatives championed by Honorable Prime Minister Narendra Modi ji, Make in India, Atmanirbhar Bharat, Skill India, this country has been building exactly the kind of indigenous innovation, advanced manufacturing, and high technology skill that a vehicle like this is built on, and which is why today's mission is of utmost national importance.
Yeah, and in some of those initiatives that you mentioned, we also have Gati Shakti, which has essentially eased the way we get approvals and get things done. For what could used to take years on end, now is simplified to a matter of minutes just sitting at home.
अवश्य, किंतु उस तीव्र गति और तीव्र प्रगति का बड़ा भाग एक महत्वपूर्ण मोड़ से जुड़ा है, जो कि 2020 में ऐतिहासिक अंतरिक्ष नियमों के परिवर्तन के परिणाम स्वरूप जो इन स्पेस संस्थान की स्थापना हुई थी, और इस संस्थान का कार्य शासन तंत्र और निजी अंतरिक्ष क्षेत्र के मध्य एक समर्थ, सुगम और दूरदर्शी सेतु की स्थापना करना था, जो कि काफी कठिन कार्य है। और स्काईरूट जैसी सभी संस्थानों की ये यात्रा को सशक्त और आधार प्रदान करता है। इसीलिए हम इन स्पेस के प्रति हार्दिक कृतज्ञता व्यक्त करते हैं।
That's right. We have live on our screens views from the launch gallery where hundreds of students, actually thousands of students, have joined us on this historic mission. These are the people who are the future of our nation, and we encourage them to join us on this journey with us to the stars, take up projects in future which contribute to the space sector and the national space ecosystems as well. Now that we've explored the significance of today's mission, let's take a closer look at what Vikram 1 is about to do in a few minutes. Of course, Vikram 1 will lift off and ascend vertically from the launch pad before executing a pitch-over maneuver, and from there it will gradually transition into what's known as a gravity turn.
That sounds a little counterintuitive, and if the launch vehicle is headed straight to space, then why does the rocket just keep not going straight up?
That's a great question, Akhil. While gaining altitude is
Skyroot
important,
LCC
reaching orbit is
automated
all about
launch
building
sequence for
horizontal
mission
velocity.
Aagaman
The gravity
initiated.
turn allows the rocket to efficiently accelerate around the Earth rather than simply away from it, using less propellant while achieving the velocity needed for
Event
orbit.
number 104.
Yeah, and
Completed.
we've just heard callouts from the Mission Control Center that the
Roger.
automatic launch sequence has been activated. It's one of the preliminary starts to the program and a very important point. At this point, the countdown is now fully automated with hundreds of onboard commands executed in precise sequence, leading us to liftoff.
And although the process is entirely automated, I believe the mission teams are closely involved, right? They have to ensure that every system is operating at its nominal health conditions.
And correct, Vaidehi, if any one of the many critical parameters that we observe in during the entire sequence goes out of its normal expected bounds, then the rocket smartly aborts the entire sequence and initiates a preloaded set of commands, and that will safeguard the entire vehicle. And then the people stationed at the ground or the engineers can have a closer look. And if the issue can be resolved within the stipulated time, then we'll have the sequence back again and we can go ahead with the launch.
Yeah, that's right. This is something very useful to have wherein engineers can resolve faults and understand if there's something that can be quickly fixed, and then we can continue back on ALS. So I think we were just talking about what the rocket does, and once stage one powers the vehicle for nearly 100 seconds, something important comes, which is max Q.
Right, you're right, Suyash. As the vehicle continues to pitch over and accelerate, it approaches one of the most demanding phases of ascent. Nearly 25 seconds into the flight after the gravity turn is max Q, the moment of maximum dynamic pressure. This is when the rocket experiences the greatest aerodynamic loads, a true test of its structural strength and engineering precision.
Yeah. So now we're at T minus 9 minutes and we're entering another crucial phase of the launch countdown. The launch team is now carrying out a final series of vehicle health checks and making sure that Vikram 1 is fully prepared for flight.
Yeah, as we can see on our screens, one of the most key milestones at this stage has been completed. That is the transition from the external ground power to the rocket's onboard batteries. Up till now, the vehicle has relied on its own ground support systems, but from this point forward, every stage must successfully power itself. And engineers are closely watching the battery performance and electrical health to ensure that this transition is very smooth and every system remains entirely stable.
Right, Akhil. With the power transition complete, attention would shift to the rocket steering system. Engineers will now be verifying that the thrust vector control, or the actuators as we call it, the mechanisms which steer the rocket by precisely directing thrust through powered flight.
Yeah, and you mentioned these actuators. Essentially, all of our solid rocket motors are equipped with what is known as a flex nozzle control. Sounds like a big complicated term, but it's quite simple. It's just the nozzle is capable of swinging in two planes, and the way we achieve this motion is by using electromechanical actuators. So you might imagine that this is something very important that we should check. So what engineers do is they perform something known as a null check. Essentially, they currently try to hold the nozzle in a neutral position. And then once that is confirmed, they provide small commands to the nozzle to deflect it. And if the response is deemed to be normal and the position is correct, we can be rest assured that the rocket will obey every command that is issued to it by the guidance computer. All right, live on your screens right now is the Vikram 1 rocket. And for a long time now, we've been looking at these views, and the biggest thing that comes out to our mind is, wow, that's a marvelous piece of engineering. And it's actually rocket science, right? There's a nearly 1,000 systems that need to work in perfect synchrony just to make liftoff happen. And that's 2/3 of all systems on rocket. So 2/3 of all system on the rocket need to work perfectly to make liftoff happen. And while it's so easy to look at the rocket and be amazed by its beauty, we would like to take a small pause and focus on the fact that behind every bolt, every wire, every line of code that is on the rocket today, it's been built by people whose passion, perseverance, and dedication have made this moment possible. Of course, a launch vehicle is never built overnight, and it's the result of countless people obsessing over one thing to make it perfect.
Exactly, Suyash. We often celebrate rocket launches, but rarely appreciate the engineering complexity behind that. And the most primary guiding principles in Skyroot is our people are our thrust. So it's not just the rocket alone that pulls the company up. It's just the people that pushing forward, pushing the entire technology forward, and all the hard work. So Vaidehi, after working on an orbital launch vehicle yourself throughout these years, what has been your biggest realizations in designing the rocket?
So one of the most important realizations which I've had is, as Suyash also mentioned earlier, rocket consists of almost around 1,000 independent subsystems, and they are deeply interconnected. A seemingly small error
T
in
minus
one
5 minutes.
discipline can propagate through
Hold
multiple
observed.
subsystems and ultimately jeopardize the entire mission. Rockets operate with extremely tight margins, so local design inaccuracies rarely remain local. This interconnectedness is precisely what makes launch vehicle design both extraordinarily challenging and intellectually rewarding. Each deviation might appear acceptable individually, but they can also collectively they can all consume all the design margins available.
Yeah. So we have a planned hold at this point. As you might see on your screens, the timer is paused at 5 minutes. So we will be checking with the internal teams, and we'll get back to you with the countdown shortly. All right. While we wait for this countdown to resolve, there's so many cool facts about space, and something really fascinating that always catches me is when Vikram 1 races through the atmosphere, it's not just fighting gravity, it's also battling extreme aerodynamic heating. And one thing that's always curious is why is the rocket heating up while it's going up in the atmosphere?
Right. So, as we are accelerating into the dense atmospheres of Earth with velocities almost 3 times, 4 times that of sound, the air in front of the vehicle rapidly gets compressed, and just outside the vehicle surface will have extremely high temperatures, which then get convected into the vehicle surface. So, just a simple question: do you guys know like what is the heat flux which we face standing on the Earth's surface due to the Earth's radiation?
I think 1000 watt per meter square, kind of. Am I right?
That's right. That is 1,000 watt per a meter square. It's around zero
There is
point
a
0.1
hold
watt per
and
centimeter
countdown.
square.
Request
When
all
Vikram
people
1
to sit in their
ascends into the
places.
Earth's atmosphere, its nose tip can face around 15 watt per centimeter squares of heat flux.
That's pretty large. I mean, as compared to humans, if we, yeah,
That's
on
right,
Earth.
that's right. And we really need to design a thermal protection system to keep the structural design under the set constraints. If we don't design any thermal protection
There is a
system,
hold
the
at T minus 5
vehicle
minutes.
surface might
Request all
end up
people to
going to
be in their
1500
places.
degrees Celsius. And
Control to all stations. There is a hold observed at T minus 5 minutes. All stations are requested to be on standby mode.
We have received confirmation that this is a planned hold and we've been advised to stay on standby. We will communicate regular updates to you, so please stay tuned with us. Can you check if they can queue us and we'll talk trivia? I don't know if the last trivia went through. So just for safety sake, we'll do the next trivia, which is Kalamwala. Like the names. I don't know if it went through, so I don't want to repeat. Kalamwala. Ask them to show commentators and QR mics. We'll continue. That's a very repeat.
I'll start igniter meet solid versus no solid. Nozzle flexing by बोल दूँ क्या?
All right. Another fun fact while we wait for this hold to resolve is we always take pride in naming our hardwares, and most of them have been in honor of some exceptional minds. So, Akhil, why don't you tell us about some of our naming conventions?
Yeah, I mean, if you can see in the rocket itself, all our rockets and the launch vehicles are named in the honor of Dr. Vikram Sarabhai, the very like father of Indian space program, we call him. And all our solid rocket motors, their names are dedicated to Dr. APJ Abdul Kalam, our very own missile man. And all our cryogenic engines, we have dedicated the names to Dr. Satish Dhawan, which we are like the center we have also Satish Dhawan Space Center dedicated to him. And then we have our hypergolic engines, Raman. And then we have dedicated that name to Nobel laureate Dr. C.V. Raman and our mission computer after the renowned mathematician Srinivas Ramanujam.
So, yeah, I think we're gonna keep up this idea of naming our hardwares after scientists.
Until we run out of scientists. Yeah.
Yeah, so I think
Not the hardware.
we need the young budding viewers who've joined us in the launch gallery to become scientists themselves and famed scientists who take India to great heights, so that we may have names.
Yes, right now, maybe. Coming to one more interesting fact, I think a lot of people, they don't know this. Like, if you look at a launch vehicle, it seems pretty rigid at first. But the interesting fact is when the entire rocket, when in flight, it experiences combined effect of aerodynamic loads, engine thrust, wind gust, and due to different steering maneuvers, the teams or the designers deliberately give some flexure, or like they make rockets slightly less rigid so that it can actually bend along its length throughout the flight. This is intentional, that designing an absolutely rigid rocket would make it significantly heavier and less efficient. And it also creates a complex engineering challenge. As the structure bends, the onboard sensors can detect these motions, so the guidance and control system must distinguish the rocket's actual altitude and structural flexing to avoid unnecessary control corrections. And engineers carefully predict these bending modes and their natural frequencies through the structural dynamics and aeroelastic analysis, ensuring the vehicle remains stable even as it flexes its way through one of the most demanding phases. And this flexure could go up close to 10 centimeters, I think. Yeah, close to 10 centimeters. That's pretty huge.
That's right, Akhil. Something for the kids who might be, looking at this live stream. So rockets don't just fly; they keep falling around Earth. It might be difficult to imagine this, but people often imagine astronauts escaping Earth's gravity. The truth is, gravity never lets go. Even the International Space Station is constantly falling towards the Earth, but it's moving sideways at so high speed that it keeps missing the ground. And that's what we call as orbit.
Yeah, that's wonderfully put.
Orbit is a state of perpetual free fall.
Yeah,
Wow.
that's right. And you spoke about how astronauts on the international space stations are also constantly falling towards Earth. And with us today in the Mission Control Center is our very own astronaut, Shubhanshu Shukla. And he's been following Skyroot's journey from a very close distance. He's part of our family as well. And he's here to cheer us on. So we thank him for his presence.
One more interesting fact for our viewers that rockets get lighter every second. Unlike an airplane, a rocket becomes lighter every second because it continuously burns and throws away propellant. Because in aircrafts we have air breathing engines,
this vehicle
so
directed
the
to all
oxidizer
stations,
itself is the air
the
that
reason
the
for hold has been
turbofan sucks in.
identified.
But when
And
you
resolved.
have a
We'll be
rocket,
reinitiating ALS soon.
when you have a rocket, you
after
cannot
finalizing
have
on a T0.
Yeah. So when we are dealing with rockets, there is no air outside air can enter and can be utilized for propulsion. So we have to carry our own bottles of oxidizers and fuel. And once the rocket is ignited and it's on its way through the entire flight, the propellant is expelled. And when the stage gets burned out, it's also thrown away or jettisoned. So that is why rocket keeps accelerating, because there is less and less mass to push.
That's right, Akhil. A rocket may weigh hundreds of tons on the launch pad. Consider our Vikram 1, it weighs around 45,000 kgs on the launch pad, but nearly 90% of that weight is just propellant.
That's really amazing that structural mass is so less. I mean,